Hi, I am Dat Nguyen. In this tutorial, I'll guide you through accessing Vision Pro hand tracking data. We'll use this data to visualize hand movement in real time with 3D objects. Here is what the final result will look like. You can see how the hand tracking data seamlessly updates the 3D objects in real time. It's worth noting that the hand tracking is much faster than what you see here. The video recording process seems to have caused noticeable slowdown in the Vision Pro display performance. Okay, let's get started. This is the main app file that we will have all our windows. First, add an immersive space into the scene with the ID hand view. We're going to make a call to a struct view called hand view. Now create a file called hand view in the left side menu under hand tracking file. Import RealityKit. Import SwiftUI. Create a struct called handView with a view protocol. Add a body to satisfy the view protocol. Add reality view and add content in. Add preview with emergentStyle.automatic. Make a call to the hand view so that we could see the preview. Create a state variable called handClass that will instantiate a custom class called handClass. Create a file called handClass under hand tracking file on the left side menu. In this class file, import ARKit, RealityKit, and SwiftUI. Create a class named handClass. Adding the main actor attribute ensures that all functions and property in the class run on the main thread. This makes it safe to perform UI updates. Adding the observable attribute allows it to notify SwiftUI view of property changes. This enables automatic UI updates when property change. Since we added the @observable attribute, our class is now following the observable protocol. VisionOS tracks 26 anchor points on each hand. We will only visualize the 10 fingertips for both hands with 10 spherical objects. These 10 objects will update continuously with the position of these 10 fingertip anchors. Create a variable root entity and set it to entity. Create a function called createSphereEntity. It will have these as parameters: name, color, radius, x, y, z. Follow the default value that is typed up on the screen. createSphereEntity will return a model entity. We're going to use createSphereEntity as a way to create 3D objects quickly, and we will add them to our root entity where it's going to hold all of the sphere entity. Inside the function, create a mesh material and add it to a model entity called entity. Set the entity's position here and also its name. Finally, return the entity. Now let's go over to hand view and add a sphere to reality view so that we could test it out. Create a reference to the hand class root entity. Create variable sphere1 and use the hand class to call the create sphere entity method. We're going to use the default value. Add the sphere1 to root entity as a child, and then add root entity to content so that we could see it in the scene. Go to your preview scene and you should be able to see a yellow sphere in front of you. If you don't see something, the preview doesn't load right away. You can always hit play to simulate Vision Pro and it should appear. Our create sphere entity method and the reference to our class root entity is both working. Head over to hand class to create a dictionary to hold our 10 sphere. Create a variable called left fingertip entity and set it equal to an empty dictionary. Instead of using a string for our key in the dictionary, we will use handskeletal.jointName enum from ARKit. The value will be model entity. Now create a function called setupEntity. This is where we will add the sphere entity to the left fingertip dictionary with their respective fingertip name. You could see the fingertip name by typing dot and going down the drop-down menu to find the fingertip that you want. We want the thumb tip. The value will be the create sphere entity. Only add the argument name. Repeat this process for the rest of the fingertips. Now add an X offset to all the spheres so that they would line up in a row in the preview. We have created the sphere, but they cannot be seen until they are added to the root entity. So let's create a for loop to add the value of the left fingertip entity to root entity as a child. Let's head back to hand view. Delete the previous sphere. Call the setupEntity method from hand class. Let's go to preview to see the 5 sphere that will be tracking our left hand fingertips. Okay, we have this sphere. Now we will go back to hand class to set up hand tracking. Create a variable session to call ARKit session to handle augmented reality input from the world. Create a variable called hand tracking to call hand tracking provider. Hand tracking provider gives hand tracking data in real time. We need to create a function to check that hand tracking is supported and the hand tracking provider state is initialized. Let's go over to hand view. After the sphere entity and root entity is created and added to reality view, we need to start the ARKit session and also enable hand tracking. Place a task after reality view. Since this could fail, we're going to use a do catch to throw any error if it does. Make a check hand tracking variable to hold the result of hand class.check hand tracking. Use an if statement to print a pass or fail for check hand tracking. Use try await to have the ARKit session run the hand tracking provider. If there is an error, have the catch print an error message. Now that ARKit session is activated and hand tracking provider is enabled, we need to get the hand tracking data. Let's head back to hand class to write a method that will handle that. Create a function called continuous hand update and make it asynchronous. Inside the function, use an asynchronous for loop to continuously listen for hand track updates. On each for loop update, you will get an update for either the left or right hand. If you print the update out, this is the result. Notice how the chirality can be left or right for the respective hand. Save the anchor update to hand anchor. Add a guard for hand anchor is tracked to ensure hand anchor is not nil. Inside of hand anchor, there is a key called origin from anchor transform. This is the world space transform for the hand anchor. By accessing the transform, we get the rotation and position of the hand anchor. Create a variable called hand anchor transform. Set it equal to hand anchor dot origin from anchor transform. Now that we have the hand anchor transform, let's track it and visualize it. At the top, create a new variable left hand anchor entity. Set the type to model entity with an optional. Inside setup entity, set the variable to create sphere entity. Left hand anchor entity is equal to create sphere entity. Put the name left hand anchor entity, color blue, radius 0.03, and an x offset of -0.3. Setting the radius to 0.3 so that it would be on the left side of our other sphere. Add it to the root entity as a child. Now let's check the hand view to see if the hand anchor entity appear in the preview. Okay, we can see that the hand anchor entity has appeared correctly as the blue dot. Jump back to the hand class file. So now we have our left hand anchor entity sphere in the scene. We need to continuously update the orientation and the position of the left hand anchor entity to that of the hand anchor transform. Set transform matrix will allow us to do this update with hand anchor transform. Set the relative to nil so that it would be in the world space. Since the hand anchor can either be left or right, we need to specify that we only want the left hand anchor and not the right. Make an if statement with handanchor.chirality equals .left and place the entity transform update inside it. Head over to hand view and add another dot task to run handClass.continuousHandUpdate method. You need to add a wait before the function call, since continuous hand update is an async function. Go to Content View to connect the hand view into the scene. Access the environment. Open immersive space as Open Immersive Space. After the text window appears, open the immersive space with ID Hand View. Before we can view hand anchor entity with Vision Pro, we need to update our file to allow hand tracking and world sensing. Head over to the left menu and go into the info file. Under Information Property List, add 2 new lines by clicking the plus sign. You can find a copy of the 2 lines in Extra Resources. Copy and paste these into 2 new lines. NS hand tracking usage description tells the user why the app needs hand tracking. NS world sensing usage description tells the user why the app needs the world environment. Now you could hit play to view the hand tracking app on Vision Pro. As you can see, the left hand anchor entity is tracking the left hand anchor transform in world space correctly. The hand anchor transform is located at the wrist. VisionOS only gives us the position of the fingertip in local space that is relative to the left hand anchor transform. To get the fingertip transform into world space, you need to add the fingertip local space to that of the world space hand anchor. Now let's get back to hand class. Go to the continuous hand update function. We have the hand anchor transform in world space. Now we need to get the fingertip local space position. Make a guard to protect against nil variables. Type let thumb tip joint equals hand anchor and access the hand skeleton. This requires an optional in case there's no hand skeleton. If you type a period, you can see autocomplete provides you a list of different joints that's available. We're going to select dot thumb tip. If you print out thumb tip joint, you will get a few accessible values. We only want the anchor from joint transform. The anchor from joint transform gives us the local transform from the hand anchor to the thumb tip joint. Let's modify the thumb tip joint to give us just the transform. Apply all of this to the fingertip joint. Add transform to all the names. Both transforms are in a 4x4 matrix table. To add two matrix, you just multiply them together. Create a variable thumb tip world transform is equal to hand anchor transform multiplied by thumb tip joint transform. Do this for all the fingertips. Now with the fingertip world transform, we just need to update it to the position of our fingertip entity. Just like our left hand anchor entity, we must make sure that we are updating the correct side of our hand anchor. Inside the hand anchor dot chirality equals dot left, access the thumb tip entity stored in our left fingertip entity dictionary. Add an optional in case it's empty. Use dot set transform matrix to update the thumb entity to the thumb tip world transform. Do this for the rest of the fingertip. Make sure you comment out the print update. That completes our code. Now you can test out the app with Vision Pro. Success! The fingertip spheres are tracking the fingertip anchor. The hand anchor sphere is tracking the hand anchor. If you move too fast, then the hand tracking isn't able to keep up with your hand movement. We are done coding for the left hand. As a challenge, see if you can code for the right hand. This is a good way to practice. When you're done, come back for the answer. Okay, I will go over how to do the right hand. Create variable for the right hand anchor and a dictionary for the right fingertips, respectively. Create entities for the right side. Add the entities to the root entity. Repeat the process for the right fingertips. Down at the hand anchor.chirality, if the chirality is not equal to left, then it is by default equal to right. Copy the same code from the left hand side and switch the entity to the right side entities. That's all you need to get the right hand. Let's test with Vision Pro. There you have it, both hands are now tracked. You can add more track joints using the same process. The tutorial has taught you everything you need to know to complete it all. In part 2 of the hand tracking series, I will show you how to place a watch on your wrist and have it track your wrist movement. Thank you for learning with me, and I hope to see you in the next part.